What if I told you that the MotoGP bikes that you are watching on television cost more than your house or even more than your entire apartment building? In this video today we're gonna deep dive and break it all down piece by piece what makes so expensive these amazing machines. So subscribe and hit the like button because we are just getting started. Let's get right together. But now let's start with what makes the bikes go. So the engine itself. So the engines cost around 200,000 euros to 250,000 euros each. These are not typical engines that you ride in your normal street bikes. These are production engines, of course. MotoGP engines takes unique forms, as you may know, so these are uniquely manufactured for this specific series. But why is it so expensive? Of course, first of all, the performance. These engines are designed to hit above 14,000 revolutions per minute with over 250 horsepower packed into a 1000cc machine weighing around 157 kilograms. That's more than double the horsepower to weight ratio of a Ferrari. So there is no one size fits at all. So for each rider, they have a preference in responsiveness, in engine braking, for example. So of course, each engine manufacturers for each chassis. But here's the catch. MotoGP engines have a specific lifespan, and throughout a season, they replace it several times. Therefore, you need to multiply the 250,000 euros by several units, and you are already nearing €1,000,000 per season.
Let's talk about intelligence, because MotoGP bikes not only fast but really intelligent. These modern electronics what keeps the bike on the track cost more than 100,000 euros, more than your average bike. So, what exactly are these electronics? We have traction control, wheelie control, engine braking, and of course the other helping devices such as ride height device, front and rear. Let's deep dive. Let's talk about traction control. Have you ever tried sprinting on an ice without an ice skate? It feels like this on the track with MotoGP bikes, also by superbikes. Because you have such a big power in the rear wheel, it just spins constantly and you can't put the power down to the ground. And what we always really do, that for example also MotoGP bikes and superbikes put the complete 250 horsepower to the ground at around 4th gear over 200 kilometers per hour, because until that you're just killing your tires and not going anywhere, just spinning your rear wheel. So traction control really comes in hand when you try to put the power down to the ground. Engine brake is when you deaccelerate into the corner. The engine works like a reverse thrust in an airplane, that it pulls the bike back through the rear wheel. So the engine works like also a brake, and we can adjust this corner by corner and lap by lap, which really comes really handy. And if you ever felt that you are braking into a corner and you accidentally push a half neutral, you cannot stop onto the corner because engine brake has such a demanding factor in the braking, and also about the bike stability. So of course we set up the suspension in a way that we calculate the engine braking into it, and that it will help to stop the bike into the corner and also rotate the bike into the corner. Such as there are many guys who like to use more engine brake, and some of them like me, I don't really prefer engine brake in a certain level, of course, but I'm not that keen on really strong engine brake because it can make the bike feel very tense. Launch control and ride height device comes hand in hand. Of course, you use the ride height device multiple times during the race, but its main focus is coming from the launch. So modern MotoGP bikes for this season have the front and rear ride height devices, which lowers the bike rear and also the front. So it acts like a drag bike. That's why they can gain enormous speeds in under seconds. Even my superbike, my best start from 0 to 100 was 2.6 seconds. It's basically beating a Ducati, and it's really enormous. So what launch control does essentially, so when you're in a start grid, you put the first gear, it activates, and you have to pull the full gas, and then you have to drop the clutch and believe that the traction control and the launch control will help you prevent your wheelies and you can make the best start possible. We could really deep dive in how these things work, and I will a bit, essentially. So I would talk about superbikes now because I'm more concerned about these. So even in superbikes, we can make the traction control engine brake work corner by corner. We make it by a lean angle sensor. So I have different engine brake and traction control splits every corner, and I have to get really used to it. And you have to, as the rider, you have to give very good feedbacks to the mechanic or engineer that what do you want in each corner, because then they can make you a good bike. And then we have the split throttle, also what MotoGP bikes have. When you are coming out of the corner And these bikes are 1000 ccm and 4 cylinders. And there are many times in slow corners in like first or second gear, we only use 2 cylinders to come out of a corner until a certain speed, and then all the 4 cylinders are working in full power to towards the straight, but it mainly prevents the rear wheel spling and the traction control intervenes so much because it makes it slower. So of course, as I mentioned in another video already, we have many buttons on the steering wheel, and we push it corner by corner and lap by lap to adjust everything we want in the bike, especially wheelie control and traction control. We have many adjusting in the handlebar, and then if you prefer in one corner a little bit more traction control or having used tires, you might want to use it in a lap or two.
Going fast is fun, but stopping safely at over 350 km per hour is a different thing. So in MotoGP bikes uses carbon fiber brakes, which only if you just consider the front brake kit, it costs over 70,000 euros each set. That includes 3 pairs of calipers, master cylinders, 10 carbon discs and 28 brake pads. These aren't just ordinary brakes. These discs can only perform over 300 Celsius. So these are working only under extreme temperatures, and below that specific amount of number that we already mentioned, these brakes cannot perform. So therefore the riders need to warm up the brakes properly to perform in the best way possible and to be able to stop safely. These brakes can slow down the bike from over 350 km per hour to 100 km per hour in under 4 seconds. So these of course generate an amount of deceleration. So the riders experience deceleration of 1.5 Gs. Those amazing numbers, and of course this hits the riders hard, so they need to endure an amazing pressure in their chest, for example on their arms. But how, due to these amazing brakes, they can decelerate. Now here is a MotoGP secret that separates the pros from your average road bike riders. On street bikes you control the rear brake with your foot, of course, but in MotoGP many riders use a thumb operated rear brake. Compared to the street bikes, they use their hand to brake the rear brake systems, and this is called the thumb brake. But why, you are asking? Well, because many riders in corners cannot use their foot because they are not in a proper position to do so. Therefore they need to use their hands because it's always available for them. That's why it was created, to be able to use the rear brake even if they are not in a right position to do with their legs. So with thumb brake, of course, riders can even use the rear brake when they are leaning in an angle over 200 km per hour. So that's insane, I believe. Each discs were quickly under racing conditions. So throughout over 20 races season, of course, the mechanics need to repair and replace these tools, so you can multiply the costs by these replacements and you can count that it's way above an average street bike braking system.
Let's talk about the rubber. Let's talk about the Michelin sticky rubber, which is the only contact patch between the ground and the bike. These tires are specially made for MotoGP. They are slicks. There's no cutting like in a street bike or street tire. And these are especially custom made for MotoGP bikes in many different types. And also there is asymmetric tires, which we talk a bit later on. So let's deep dive now into the tires itself. Michelin reportedly spends 1.2 million euros per race weekend for the transportation, for the usage, and also for the staff. So it's an enormous amount of money if you calculate this for over 20 race weekends. A single set may be only used for 1 or 2 laps in a qualifying, but also used during a race distance. So these tires have to be really grippy and also durable. And teams decide if they go for soft, medium or hard, depending on the weather, the track and the observation of the tarmac. So for example, for a qualifying, normally some guys prefer a hard front tire so they can brake a bit harder, but the soft rear tires so they can exit the corners a bit faster and be a bit grippy. But in the long run, the soft tire might just be not the good decision because you have less grip in the end of the race. So there is, for example, Sassering, where you have 10 or 12 corners to the left and then like 3 to the right. And of course, a normal tire wouldn't handle the pressure to the left. So there is the asymmetric tires, which on the left side is a harder compound compared to the soft compound, which is really keen for the tire life and also for safety, because if you go so much to the left, your right side tire is essentially going to cool down, and you have to be very, very careful in that right turns, how you turn the bike into the corner, because you can lose the front grip quite easily. Therefore, of course, we have the tire warmers. Even an amateur track rider uses a track tire warmer, which essentially makes your tire hot before you go out, because these tires can perform only when it's hot. So let's talk about the frames and suspension of the MotoGP bike. Of course, each one is custom made for each manufacturer, and they make it in-house. And there's many different technologies. For example, KTM uses a rigid frame technology, whereas Honda or Yamaha uses a much more controversial normal frame technology. Of course, these are made for a whole season. There are multiple units, and of course, due to the concessions, for example, Yamaha can change the frame multiple times a season, whereas Ducati can only stick with one frame for the whole season. This is for the concession rules. And about the suspension, every team uses the Erlins suspension, which is the best in the market. I also use the Erlins. I've been really, really happy with them. Of course, these suspensions are on other level. So the front fork is actually made out of carbon fiber, which is good because it's really, really strong. You don't have that movement in the fork. So the frames are typically crafted from aluminium, whereas the rear swing arm can be used by carbon fiber or magnesium, because magnesium is really, really light, but also very, very easy to break. So if you're having a big crash, there's a big chance that they're gonna swap the swing arm around. And these things cost to 50 to 70,000 euro per frame. So it's really hard on the money when you crash them. So of course the suspension is fine-tuned for every rider, so every rider has different preference. For example, I like a bike which is quite middle-based or even a little bit front-based. So I like a sharp front, but many riders prefer a bit of we call it an SE bike, which has essentially more grip in the rear, so they can quite use different styles. So what I do normally with my style is that I have a quite flowing style, so I need a quite natural bike that I can have a good acceleration but also good braking. Whereas these guys who have a much more S-orientated bike, they can brake into the corner quite hard, and then they make sort of a V shape. Then they can make a good big gas and come out of the corners. And these two styles are also, looking on TV, it's hard to overtake, because there is many guys who ride in the more classical styles, and there's a new gen style, which many riders use now. This suspension can cost up to 40,000 euros per set, and of course many riders swap it during the season. Let's talk about the other materials. MotoGP uses the highest technology materials that you can buy on the market, even something that you can buy on the market. It's almost like a space technology. So they use carbon fiber, which is €2 per 100 grams, which is just enormous. Also, I think in my superbike, fairing is over 4,000 euros. So you can, with the wings and everything, and even MotoGP bikes have much more complex technology than that, so it's over 1,000 euros for a fairing. They use magnesium rims, which is around 4,000 euros per rim. Which is just enormous. I use aluminium wheels because it's more durable and also a bit safer, because with magnesium wheels you have a certain lifespan, and of course if you crash them once or you hit them on a big curb, they just go into the bin, because you have to examine them under the laser or UV light, is there any cracks in it. And they use titanium fasteners, which makes the bike even more lighter.
Racing is a risky business, of course. Even when a bike crashes, even with the lowest speed, these crashing bills can be very shocking, of course. For even a minor crash, it can cost between 50,000 to 20,000 euros per crash. For a major crash, it can be over 100,000 euros even. And for a very shocking and very extreme crash, it can be over 500,000 euros. That's an insane amount of money. And these numbers are not hypothetical, of course. Teams experience multiple crashes, even sometimes throughout a whole race weekend. Furthermore, some teams spend even over €1 million in a certain crash to replace the crashed parts or to replace the crashed bike as well. And now you're wondering, like, how much does a MotoGP bike really cost? So now we're gonna break it down and tell you an estimated price tag for each part, and gonna say a total price of these MotoGP bikes. Engines, over 1 million euros. Electronics, over 100,000 euros. Brakes, 100,000 euros per seasonal use. Tires, 500,000 euros per rider allocation. Frame and suspension, 100,000 euros. Material, fairings, rims, 75,000 euros. Gearbox and drivetrain, 50,000 euros. Crash damage, 250,000 euros. This is an average. And assembly and customization, 200,000 euros, or even sometimes more than that. So the total cost per bike per season is 3 million to 3.5 million euros. Insane. And remember, this is just one bike. Factory MotoGP teams tend to have 4 different bikes per rider. And now you see it. MotoGP as a whole, and MotoGP bikes isn't just about racing fast. It's a complete tailored battlefield of engineering, of the mechanics, of the designs of these bikes. And of course, they need a tremendous amount of investment to push the limits of this two-wheeled world. Which part blew your mind the most? Drop your thoughts in the comments, and if you like this breakdown, please hit the like button, because that's gonna help us to improve in our journey and help Shoma to achieve his ultimate goal to race in the World Superbike category. And if you don't want to miss our next video, hit the subscribe button, and see you in the next video. Ciao!
What?